Okay, so this is recording number 2 for the cosine 4x problem. Okay, so this will be very brief. Okay, so as I mentioned here, this is the family of solutions that I found before is not the only family of solutions. Here's another one. Cosine 4x is equal to blah blah blah. Here's another one. Here's another one, and you get that, as I mentioned before, from this table right here. So root 2 over 2, that's the cosine value. What's the corresponding angle? 7 pi over 4. All right, so that's a new family, 7 pi over 4 plus 2n pi. So that gives me what 4x is. As I mentioned before, 4x isn't exactly what I want. What I really want is x, so I multiply both sides by 1/4, and this is what I get. So this is my new family of solutions. I didn't go through the same routine. I want to leave that to you. I recommend that you do it every single time on these. Plug them in to kind of get the hang of it, kind of get the idea of what's going on. Now, the only other thing I can think of that I want to point out is coming back up here when we were coming up with these things. Give me 1 second. Okay, so we have this family, this pi over 16 plus 1/2 n pi. So as an example, pi over 16 plus 1/2 pi if n is equal to 1 is a common little difficulty that students have is, at least I did anyway. I look at this and I say, okay, wait a second. I get the concept that, just like the metaphor of the clock, if you have a revolution, that certainly, I understand you chime at 15 minutes after, you do one revolution, and you're right back where you started from. But gosh, we don't have that. What's going on, Mr. Wizard? We have pi over 16 plus 1/2 pi. Well, 1/2 pi, that's 90 degrees. That's not a revolution. How about down here? Same idea. When n is equal to 2, we've got blah, blah, blah. Okay, we started at 11.5 degrees. Then we add 180 degrees. That's not a revolution. What's going on here, Mr. Wizard? I don't understand. That was my first reaction. Well, get, what you need to understand is that I agree that that's the 180 degrees. That's not a revolution. The 90 degrees here, that's not a revolution. Okay, but that's okay because remember this x is going to get plugged into the argument of the function cosine. This is the argument. What is it that the function is operating on? The argument of the cosine function is 4x, okay? So it's 4x, 4 times all of this. So when you multiply 4 times all of this 4 times 1/2 pi gives you the 2 pi. By golly, that is a revolution, okay? So that's where the revolution metaphor comes up. Same thing down here. When it's 4 times pi, you get 4 pi. That's 2 revolutions. Okay. When you get down here, it's 4 times 3/2 pi. That's 6 revolutions. Okay. Or I'm sorry, that's 6 pi. Well, 6 pi is 3 revolutions. I hope I said that right up here. Anyway, so 4 pi is 2 revolutions. 6 pi is 3 revolutions. So that's where the metaphor of the minute hand hitting, going around and around and around, and you get the chime over and over again. That's where that metaphor comes in. It's not from here. It's from, or I'm sorry, it's not from here. That obviously 3/2 of a pi, that's not a revolution. But 4 times 3/2 of pi, that does give you a revolution. That gives you the 6 pi, that's 3 revolutions. Okay, I hope I didn't make that worse, but that's what's going on. I'd like to have you be able to visualize this stuff. I strongly urge you, print this out and use this all the time. It really is helpful to kind of visualize how you're revolving and where do you end up. Okay, so that's the end of this recording.